right, I'm going to just blow through some examples and then cover some quick last minute notes. These are from both perpendicular bisectors and angle bisectors. So I have DG, EG, and FG are the perpendicular bisectors. So I know I have perpendicular bisectors. So we're right here, and right here. So you can see our tiny little right angles. And what else do we know about perpendicular bisectors? That means they're hitting at the midpoint. So AD is congruent to DB, EB is congruent to CE, and AF is congruent to FC. So I like to go through and go ahead and mark up my triangle as much as I can to give myself all the information available. I also know that from my circumcenter, which is the point where my perpendicular bisectors meet, down to my vertices of my triangle are also congruent to each other. So GB is congruent to GA and GC. So AG from my vertice A to the circumcenter G, that's going to be 10 as it is congruent to GC, which is listed as 10. And then I have DB going down this side. That's congruent to AD, so that's going to be 7. AF is going along the top of the triangle here, which is also going to be 9.8. And GB, again, is going from the circumcenter all the way down to B, our vertex. And so that is also going to be 10. Then we can take a look at our angle bisectors over here. So make sure you're reading your question. Am I dealing with angle bisectors? Am I dealing with perpendicular bisectors? Or am I dealing with something else, like the things we will go over next week in 5.2? So GJ is an angle bisector. So here we go, angle bisector. So we know these two are congruent to each other. And IJ, so down here, angle bisector. So these two are congruent to each other. Give them 2 marks. Don't want to cover up that 82.1 though, so do those marks out here. And then I have a length right here, which is 64.3. So the distance from J to GH, so if I drew a line from J over to GH, that means I'm going to be doing that at a right angle since it's going to be perpendicular and it's congruent to JK. So it is also going to be 64.3. Again, don't bash on the drawings. Don't bash on if they look proportional or to scale. Okay? Just believe in your knowledge about incenters and angle bisectors, even if the picture is a little funky. All right. The next I need to find the measure of angle JGK. So JGK is right here, and that's going to be 23 as it is congruent to angle JGH. Now, some little tips and tricks. This is really important. This is about the circumcenter. The circumcenter is about the meeting points of the perpendicular bisectors. So the ones that use the midpoint and are perpendicular. When they meet, they are not always going to be inside of a triangle. They could be on the inside, they could be on the outside, or they can be right on the edge of a triangle. So these are your 3 instances. If it's acute, it will be inside. If it's obtuse, it will be outside. And if it's a right triangle, it's actually going to be on a side. So as you're graphing these, you're like, oh, this doesn't look right. This is going crazy. No, it probably isn't. It's probably exactly where it's supposed to be. Just double check your math. Now, tips and tricks to remember all of these things that belong together. So y'all don't know it yet, but you're going to learn about 2 more types of lines in 5.2, and they each have a point of concurrency as well. So that's going to be 4 types of lines with 4 points inside of a triangle. I don't say this to overwhelm you. I say this to prepare yourself that trying to remember these is going to be real important. And so sometimes coming up with a mnemonic device or something you can repeat in your head that will help you remember is helpful. So I have found, as many of us have found, that coming up with phrases helps. So one of my favorite candies is Reese's. And so that's made up of peanut butter and chocolate and perpendicular bisectors. So peanut butter, perpendicular bisectors intersect at the circumference, or chocolate. So peanut butter chocolate is perpendicular bisector. One of my favorite ice cream brands, of course, is Bluebell. Gotta love it. Love going to Brenham. Love going to tour the factory. Gotta eat as much Bluebell as I can. Um, and so my slogan is always Bluebell ice cream. And so that stands for angle bisectors that intersect at the in center. So angle bisectors, always Bluebell. In center, ice cream. So always in center. It's silly, but I promise you, these do so much help in trying to remember them. So you'll see in 5.2, you'll learn 2 more funny phrases, but as long as you write them down or remember them in your head, they will absolutely help you.